Where'd the
Flex
biscuits
for
drifting?
1, 2.
Okay, I'm going to be talking about some of the components
Where's my
of the
Triscuits?
flex form table here. This is the working prototype for the flex form system. It has the full frame, the table with the hydraulic core, and that's it. There's little components to it that I'm going to walk you through. So the table deck here is made of 3/16 hot rolled plate that has been powder coated. It has a countersunk spot on it to receive a machine screw that mounts the plate sections to the steel frame, which is made of C-channel and angle iron. The plate sections are split, one at each end and one full length one that can be disassembled, replaced, cleaned, repowder coated, whatever, as it gets old and damaged. Steel is pretty durable. The finishes can get damaged over time though. I put a tape measure that is built into here, just like a table saw would have. This tape starts out at a center point of the table. You have a left marking measure and a right marking measure. So what you would do is set your mold body inside of your rubber frame on center of the frame body. That frame body sits exactly center of this table. Okay, so what you can do on here is take a T-square, and I think it'd be really cool to have a T-square. This is just kind of dumbing things down and making things really easy to wash. You know, this tape is made of a metal that's got a washable surface on it. It's very flat. The T-square isn't part of the table, so it can be taken off and cleaned, and probably won't really get any mess on it ever. So what I was thinking is having a custom square made that would reference at your starting point of your frame and your ending point of your both inside and outside of your frame. And then it would then have measurements in 1-inch increments and breaking down into 1/8, 1/4, 1/16 from that point on. So it would be a T-square made for the flex form table that could be kept with the table on a hook, just like some of the other parts to the table that stay with the table at all times. There's this little box full of the flex form goodies. There's the brackets that hold the form body to the flex form frame. There's the little horseshoe shims that level out different thicknesses of rubber. Some of the screws and things that are needed for some of the parts to the mold. Okay, so the base of the table has 3 independent scissor lifts that run on hydraulics that raises and lowers 3 table sections on the flex form table. These table sections have a steel plate top which flushes out here to the perimeter, but it has a magnetic sheeting on it that creates a protective barrier here and also gives you an area to really make clear marks on your center points and armature positions. The scissor lifts have a brake release here. This releases the hydraulic. There's one for the center one down at the base. There is one at each end that controls each scissor lift at each end. This is the foot press on the other side. I'll walk around that side here in a minute. That controls the center one. These are set pins that keep the table at its finished height so that the hydraulic doesn't end up dropping out. I've been having some problems with 2 of these scissor lifts. These are Harbor Freight scissor lifts. They're not very good units. The hydraulics don't work very well on these. The end one stays up in position. The middle one, I had to bleed all 3 of them first of all. They were all dropping at a pretty fast rate, and I had to top them off with some hydraulic fluid and bleed out any air that may have been in there, and it only really corrected the problem for one of them. One of them still tends to fall quite a bit, and the middle one's doing a lot better now, but then it has a problem with the brake. The brake releases the table top too fast, so what I was thinking was doing some sort of hand crank for each table section at the far ends, and then there would be a hand crank here for this one that would run a piece of all thread that would kind of wind the scissor lift up and down. That would give you a stopping point at any given height once you stop spinning the all thread. It's a very simple system that is sort of foolproof. You can't break it. I mean, I guess you could break it, but it's very difficult. There's very little to it. The hydraulics are much touchier, but you could have some sort of measuring guides for each table section that have a gauge at the heights that that table is also traveling. And once you stop turning it, the all thread will just keep it at that position. You could put a little pin lock on it so that the wheel can unwind if you end up, if your leg hits it or something, it just keeps it right where it needs to be at all times. The table has a leveling foot at both sides, which gets the sag out of the center of this table. This table is very heavy and it has a long span. It's actually 13 feet long by 4 feet 2 inches wide. So that span with the weight and the weight of everything that's on it gives it about a 1/8 to 3/16 fall, and this just points it all back up and trues it up, and it also keeps the table from moving around. Okay, so we have the main components of the table core. You can drop these up and down. You can use it to help you demold. You can bring armatures up into your piece. You can drop. You can help it. You can use it to help pull the rubber downward. If you wanted to create a very up and down sort of mold. This is a little kickstand I put in. This thing can be shrunk down considerably. It doesn't need to be nearly this big. These were just some scrap parts that I had laying around the shop that I had to quickly throw on here and get this thing working for last class. So there's a little quick release pin here. I had a screw that I used to have to put in here, and now I can just pull this out and the thing drops. It just slips right out. It's super easy. So we have the pins back here. There's the foot press for this side. There is the leveling foot. And I'm going to drop this down. You can see how this mold stays suspended with the frame. Drop this down. It's pretty cool because it's really, even for a frame that's this large, it's a one-man job to lower it. The aluminum's great material. It's very light. It'd be nice to have the aluminum powder coated though, and have like all the main core sections with this yellow finish to them, so you can really have the materials offsetting, and the aluminum would be easier to clean. So here's how the rubber mounts. Actually, I'll start with the frame first. So we have a end cap to each section of the frame. So it consists of, the main section of the frame consists of 4 parts, and then the rubber mounts also consist of 4 parts. Each frame end has this bracket that is welded to it that has 6 screw points, and then this other section has another lapping bracket that laps over the top with 2 screw points, so you get kind of like a lap joint. here. Because you have these 6 screw points and it goes fairly deep into this frame, you have really great shear strength here, and you have even more shear strength, and it helps keep this piece of tubing flat. This frame is made of 2" by 3" aluminum tubing, 3/16 wall. I may want to increase that if the screw system stays here, just to give you more threading points, so it might be a 1/4" wall. And it's not going to add a whole lot of weight to it because aluminum is very light. So we have a standard type door hinge on here, which is actually a great hinging system. It helps keep the form frame, actually the rubber frame, down to the table and keeps it flat. We have one on center and one on each end. If you need to take this frame off, you can just knock these pins out, just like you would on a door, and take the frame off, and you can use this thing as a casting table if you're not using it for any sink molding purposes. You could, lay a sheet of wood over it, or just put your mold directly on it and cover it in plastic, and it gives you another 13-foot by 4-foot casting table. So it's not just hogging up room in the shop. And it can still help you flip pieces. The hydraulic table can help you flip your pieces with less effort, because you can drop the table sections down, add some material to it, and then jack it back up, and it'll help give you some lift off of your table, so you can get your hands under it, and gives you partial lift, so you can start your rotation a little easier. Okay, so we have a piece of aluminum angle. This is also 3" wide by 2" deep. And what the angle does is it sandwiches the rubber and gives it a double fold, so it does sort of a zigzag thing here. Because of it taking 2 turns and having compression on it, keeps the rubber seated in. You do have to penetrate the rubber here, but that rubber only has penetrations at parts of the rubber that you're not going to use. They're outside of your mold area. So you have these screw mounts every couple feet here that holds your rubber on, and then we have these form mounts. Actually, let me go back to the horseshoe clip here. These are put in to keep your aluminum angle at a 90. This makes up for the thickness of your rubber. Depending on the thickness, if you have 1/8 inch, you have an 1/8 inch shim. If you have a 16th inch, you have a 16th inch shim. If you have something thinner, then you probably wouldn't need this, because it's just going to seat so close to your actual frame. So you need that at a 90, because when you put your adjusting bracket on here that holds your actual form in place, it has to be at a 90 in order to keep your mold face at a 90. So you have to have a melamine beam, is basically what it is, a minimum of 4 inches. So you have to build a 4.5 inch box around this section. So you have a full 4 inch box, and then inside of that box, you then have your actual casting mold. So you increase the size of your mold by 1.5 inches, and then you build your casting depth to the inside. So this one's 3/4 thick. So I have this, guy that comes up, and this would be the dropped edge. I just threw this in here for reference. It took me no time to set this thing up. It's very, very fast. You don't need mounts on the end because these short spans are so strong, 4.5 inches. If you have screws in the side here, there's not enough pull in your rubber to bother that at all. It's not going to flex anything. We have about a 2 inch center distance between here, which is plenty of strength at 2 feet. It will not bend 4.5 inches of thickness on your melamine. Again, over here it's the same thing. We have the lap joint on all sides. We have 3 handles for your lifting, depending on which side you're going to be operating, or if you have another guy over here helping you. So you can disassemble the whole form and break it away and store it in on a wall too, and roll your rubber back up and get it off the table and have your casting table, and this thing's ready to go every time you need it. So I'm going to drop a couple armatures under here real quick. Let me lift this guy up onto the kickstand. See here, see this little pin goes right in. Okay, we're back up here. So if you wanted to create a rigid mold out of this, you would spray a plaster backer across the section of rubber that you're going to use. So you can see a silhouette of your mold frame. You just spray a little bit beyond that. You got to run tape to protect your frame. I'm going to actually cut some steel profiles out that just quickly clamp on, or even maybe put like 2 screw mounts in it, and it'll screw onto the bottom of this frame. So you spray your plaster and you take it off, so you're not having to tape things up every time, and then you can take those things out and wash them outside or wherever your clean out area is. Okay, so I just have 2 real dumb versions of armatures. These are standard sinks that people tend to make all the time with fabric form. They have like a little organic shape that just sweeps into a standard drain, and they spent a lot of time sanding and stretching fabric and bondoing, and not very fun. Okay, so we have 2. I just had a couple of measurements I struck out there. They're not very accurate. I'm just gonna drop this over. Typically you would hot glue down to this magnet backed vinyl, and the hot glue bonds good to it, but it also comes off fairly easily too. It's just enough grab. Okay, we're going to drop down here. Just plunge up. And there you go. You have your double basin sink. So if you're doing plaster, you're going to want to drop your armature down. These are actually really steep. You can see how this one's sort of kicked, because it's another reason why you would... These are pretty deep. These are 6.5 inches. So on your turn down, when you're coming down, the rubber is going to rake that a little bit. It's not just dropping straight down into it. So you can drop your table section down to bring that up into the rubber. But when you're just checking out your mold to see if it's the way you want it, you don't need to do that. But when you do spray your plaster on it, I would recommend bringing that armature into the plaster. But that's about it. So figure it out, whatever configuration you want under here. You could even produce like certain armatures that are all interchangeable and sell those as a product too. Maybe some that are magnetic and they stick down to the table. That way you don't have to glue anything, and it doesn't disturb anything. It just has a strong little magnet, and you can just move it around, walk it around, change positions at will. And it's just enough to hold it. Made out of a material that's washable, because it's going to get plaster on it. And you got to be able to scrape it back off. Anyhow, that is the walk around of the components to the FlexForm table.